Hi, this is Don Gettner with Ridge Engineering. In this tutorial, I'm going to show you a new feature that we've recently added to PC Warrants. It's the ability to factor right turns from the approach volumes in a very detailed way. I'll explain how this works as I go along. I'm going to run PC Warrants, and this is version 1.18.2, which is now available on the Downloads page. And you see the standard startup options screen, and I'm going to open an existing signal warrant study, and I'm going to pick demo 2, which is a little test file that I've been using, and I'm going to go to the volume data screen, and you can see that there are some obviously fake numbers that have been added to the midnight totals. These are done just to show you what the right turn factor worksheet does when it's operating. There's some numbers in each interval for each approach on the right turn, so that we'll have some right turns to actually factor. And there's also some values in the through movements, the northbound through, that will show how an advanced feature works. And we'll get to all this in a minute. So I'm going to click on the factor data button. Now this factor data has been in PC Warrants all along, but it was just the stuff on the left side of the screen here, which are, it's kind of a rough global way of factoring the data. You could factor all of the values of various movements by a specific factor, but it was all of the volumes from midnight to midnight. Or you could set a global factor, say a growth factor of 1.15 for a 15% growth of the entire intersection. Or you could just set all of the lefts, all of the throughs, and all of the rights, multiply by a factor. But we had people that asked us for the ability to be more granular, to be able to factor the right turns on an hour-by-hour basis as well as on an approach basis. So we recently added this second part of this screen, and this is the ability to edit and create factors, multiplication factors, for each approach and for each hour of the day. And so the software shows the right turns from each approach, and also there's a white column for the factor. And if this button is in the copy mode, then whatever number is here is simply transferred to the cell when you click on it. And if I change this to say 0.5, and I can do a few of these. So it's very quick to go through and edit individual factors if you know what the value should be. If I click on the copy button, it changes to edit, and that lets me edit an individual cell. So I can change that 1 to 0.35. Maybe that's a little quicker than editing this. So you have these two ways that you can edit the numbers. Once you've done that and you click OK, whatever numbers are in the factor columns are multiplied by the volume, the right turn volume, and those numbers are transferred back to the regular volume data matrix, which then you can use to finish the warrant analysis. So this is a way of sort of globally setting the values and also setting the values on an hour-by-hour basis. But we also have people that have an even more detailed procedure that they wanted to follow. The state of Ohio, in particular, has been working with us to come up with a procedure that they've been using for many years. And it now has been implemented in this. And if you want to get to that procedure, you click on the ODOT button. Now that brings up a new screen, and it's fairly involved, but I'll explain what's going on as we do it. Now the way this procedure works, it's based on a procedure that's published in the Traffic Engineering Manual of Ohio DOT, and it's also in a couple of other states where this procedure has sort of been popularized over the years. And it works in two steps. The first step is to find a minor leg lane configuration and right turn reduction for the right turns for that approach. So for any given approach, the first thing you do is you pick which of these 5 configurations most closely resembles the actual approach you're modeling, you're working on. And say it's number 1. Then you calculate the volumes, the left turns, throughs, and right turns, and the sum of those is the approach volume, the A. And then there are a series of tests. So for example, if R is greater than 0.7A, if the right turns are greater than 0.7 of all of the vehicles, then you reduce the right turns by 60%. And so there are different tests for each of the configurations, and you can see how a computer could be used to help make this work. Many people have developed spreadsheets, Excel spreadsheets, to work on this. So this is what we're doing in PC Warrants. We're going to implement this as well. Now they recognized that this is only part of the equation. The other part is shown in the next page, and this is the mainline congestion factor. Now, if there's a lot of traffic on the main line through, that might prohibit cars that would normally make a right turn from making a right turn. So you have to reduce the right turn factor as the volume on the main through movement increases, because again, those right turns will find it harder and harder to make a right turn because there just aren't going to be as many gaps. So if there are 100 vehicles that wanted to make a right turn, but the traffic was really, really heavy, then maybe only 50% of them could make it. And somehow they came up with these values, and we're using them in the software as well. So first you do the first procedure to find the right turn factor, and then you do the mainline congestion factor, and you take whatever reduction you have here from the right turn factor, and then that's the actual reduction that you apply for that hour. So you do this for each hour. So you can see you wouldn't want to do this by hand, which is why computers are nice. So we have this worksheet, and first of all, we have pictures of the 5 configurations so that you can remember what they mean. And then the volume data matrix is reproduced, and whether or not the streets are major or minor are shown. And for the minor, you can select which configuration you want to use. Say we want to use configuration 3 for the eastbound, and configuration 2 for the westbound. They don't have to be the same. Right? Now, once I've selected both configurations, this calc button at the bottom turns green. Now, over on the right are going to be the results of the calculation. Now, first, the software disables the major approaches because they're not of any interest. We're not going to reduce those numbers by anything, so they're set to 0. And there's 2 numbers that are going to be calculated: the base right turn factor and the mainline correction factor. So I now have these values, and I hit calc, and the software uses the procedure that I showed a minute ago on each hour, and it finds the base calculation, the base factor, and also the main line. And if you work through, you can see that we picked number 3, and that's a reduction of 0.75 in all cases. And on westbound, we have some numbers that it calculated. I'm not going to go through exactly how it all works, but you can get an idea that it calculates that, and then it takes the difference between these numbers. So for the westbound midnight, which of course doesn't make sense because these numbers are artificial, it would say we're going to start with 0.6, but because of the mainline traffic, we're only going to take 0.5 of the right turns out. So when I hit OK, it takes these numbers and moves them back into this worksheet. And you can look at them, and if you want to, you can, if you want to change something for whatever reason, you can edit them. And then once these have been edited, which normally you wouldn't do, you click OK, and they get transferred to the right turns. And now this volume data matrix has been edited, and you can continue to do your warrant analysis. So it's a little bit hard to explain, but it's actually very quick. You simply select the configuration for the two minor approaches, whatever they may be. That's really the only decision you have to make. And then you hit the calc button. It comes up with numbers. You say, oh, typically you'll say okay. Typically you'll say okay, and you're done. So it's that fast. So we think this is going to be a very nice feature for people that really want to reduce their right turns. Of course, it only works if you have right turn values for your data, which means you're going to be doing turning movements for your approach volumes. And we're finding more and more people are doing long turning movement counts, partly to be able to do this type of analysis. There's a lot of other reasons why long turning movement counts are useful. And so if you're now using road tube counters to do your approach counts, you might want to think about using some technique to do turning movement counts for those 10 or 12 hours for the warrant analysis. And then you can apply this type of logic to get a much, much better warrant analysis, get the volumes right where they really should be, and more representative of what is really out there. And it'll tend to get rid of some of the right turns, which for most people is a good thing. So give us some thoughts. That's it for now. I hope this made sense, and if you have any questions, just let us know.